session, and I am going to discuss everything about competitive based syllabus. Okay, today's session is all about the topics which are mostly asked in competitive exams, and I hope this will be helpful, and you can just ask anything that does not make sense, or if there is anything particular that you want me to discuss about, please let me know. You can also suggest what books you want me to cover it for you, or if you want any specific books that you have and you want me to make lessons on that, I am open to doing that as well. So, in competitive exams, the basic topics that you have is all from your school topics, okay? And the thing is, in school time, we used to do each question with multiple steps. Now you don't have that much of time, yeah? For each question, you will get almost like 30 seconds, and within that time, you have to finish each question. So the approach here will be a little different because we are not showing our steps. We have to approach in the shortest way possible. So let me help you with everything that with the best of my knowledge, honestly. And you can definitely approach questions in a very different way as well, right? There is not just one way of approaching questions. So just let me know whatever things seems doubtful to you. We can just go through that. So let's get started. So this is the first question here. It is from time and work. Now, it's very important to note one thing. Time and work follows an inverse relationship, meaning if you have more time, then the amount of work you complete is definitely more, but the number of people, if you consider number of people, then obviously more number of people means less time taken. The similar approach is considered when you consider question from speed and time. So speed and time, again, more time you give or more time you're taking, that means your speed is low. More speed you have, then the time taken will be lesser. So these kind of questions can be approached in multiple ways, but I'm trying my best to do it in the shortest way possible. Let's get started. Here is the first question. If you are already looking at this question and you know how to do it, please go ahead and solve it by the method that you know. Mohan can do a work in 15 days. After working for 3 days, he is joined by Vinod, and they complete the remaining work in 3 more days. So this is all the information that you have. You're supposed to find out the time taken by the second person, Vinod alone. How would you approach this question? Now, in school time, we do make this long work, yeah? We just solve in multiple steps and we show our working clearly. But here, because we don't have to do that, we will approach in the shortest way possible. We know that Mohan can work in 15 days. So his 1 day work, he'll be able to complete 1/15 of the work in 1 day. Yeah, that portion of work will be completed. Now, the main information here is after working for 3 days, he's joined by Vinod. So the main thing that you can look at is this person, Mohan, is not just working for 3 days, he's working for another 3 days along with Vinod. So total number of days that Mohan will work is 6. Okay, Mohan will work for 6 days. So when I know that he alone works and he completes the work in 15 days, his 1 day work is 1/15. So clearly in 6 days, he will complete 6/15 of the portion. I'll just times the 2 value, giving me 6/15 of the work. So this is the work done by Mohan alone in all the 6 days. Once you have figured out this is a fraction which you can reduce. Both are divisible by 3. So 3 times 2 is 6, 3 times 5 is 15. So Mohan alone does 2/5 of the work. So clearly, the remaining work is how much? To find the remaining work, you would just find the difference of the two values, 2 and 5, which is 3/5, okay? In fractional form, we have to write it because it's just the work is one whole. So 3/5 of the work is to be done by Vinod, the second person. Now we know that Vinod works for 3 days, right? So 3/5 is the work remaining, and this is the work done by Vinod. This is the work. If I divide work by number of days, then what I'm getting is I will get the work per day. So 3/5 divided by 3, how can you do it? Very simple logic, same numerators, you can cancel them out, giving you 1/5, which means this 1/5 is basically the 1 day work of Vinod. All right. Now, if you know that he completes 1/5 portion of the work in 1 day, then clearly he'll take 5 days to complete the work, right? So just when you found out the 1 day work, the reciprocal of that gives you the total number of days he will take if he works alone. So the answer clearly is just 5. Okay, so 5 days. There is a similar question like this, and you will see that if you'll follow the technique, I'm sure you will be able to do it all by yourself. You should try this question now. Similar one, A can do a work in 12 days. When he had worked for 3 days, B joined him. If they complete the work in 3 more days, again this person A is working for 3 days along with the second person, he is working for 3 more days. So total number of days A will work is definitely 6 days. Yeah. So if he's working for 6 days, times it by the 1 day work of this person, which is, because he's completing in 12 days, his 1 day work is 1 by 12, which is just 6 by 12. I can reduce that to 1 upon 2. So A is doing half of the work. A will complete half of the work. So the remaining work is clearly, remaining is just half because 1 whole is the work. So half portion is now completed by B. Now note that B works for how many days? 3 days. So I divide by the total number of days he is working to find out the 1 day work for the second person. Again, 1 by 2 divided by 3, 1/6. I have to cross multiply. The other way you divide is you cross multiply because this 1 has no denominator on the other side. It's just 1, and 2 times 3 is 6. So 1/6 is the work, or 1/6 portion of work is completed in 1 day by the second person. Clearly, the number of days he will take is simply the reciprocal, so answer is 6 days. So these are the questions from time and work. Yeah, this is how you can approach questions, but sometimes the questions can be a little twisted. So how exactly can we approach a question like this? Arun can do a certain work in the same time in which Bipasha and Rahul together can do it. So same time as in, obviously the time taken is the same, which applies that 1 day work of Arun, A, will be same as the 1 day work together for Bipasha and Rahul, which is 1 by B plus 1 by R. Okay, that's our first relation. Now, the next information, the information where all the numbers have been given to you, if Arun and Bipasha could do it in 10 days and Rahul alone in 50 days. So, Arun and Bipasha together does in 10 days. So, clearly their 1 day work for Arun and Bipasha together, 1 by A plus 1 by B plus 1 by C. Why am I taking all 3 of them? Because I have the numerical value for 1 by A plus 1 by B. The 1 day work of A and B together is 1/10 because they are taking overall 10 days. Now, not C here, we have R, the person Rahul. Now, Rahul alone does in 50 days. So if he's working along, then his 1 day work has to be added with the 1 day work of the other two, which is 1 by 50. Now think about this. You can reduce this, you can add the two fractions here. 10 and 50, they have a common LCM, or the common denominator is 50. 10 times 5 is 50. So this becomes 5 upon 50 plus 1 upon 50, which is just 6 upon 50. Okay. So 6 upon 50 is the 1 day work of all three people. Now using the first information, I know that 1 by A, that is the 1 day work of Arun, is equal to 1 by B plus 1 by R. So clearly, if I'll go ahead and swap, instead of 1 by A, if I'll have to consider 1 by B plus 1 by R, then it's clear that the 6 upon 50 is the 2 days work for 1 by B plus 1 by R, or if I'm assuming this 1 by A, if I swap this 1 by A by 1 by B plus 1 by R, I'll get this part twice, right? So I can say that twice the work of 1 by B plus 1 by R has to be 6 upon 50. Now, because it's multiplied by 2 this side, and I know I have to find the 1 day work for Bipasha, 1 by B. If I'll find 1 by B, then I can find that B value. So clearly, I know 1 by R here is 1 by 50, because I know the work done by Rahul alone. So let's get rid of this 2 first. 6 and 50, both are reducible first of all, so I can reduce them, yeah. And then divide by 2, if I bring that 2 this side, it will simply be 3 upon 50. So 1 by B plus, instead of 1 by R, the 1 day work of Rahul is just 1 by 50 now. Now bringing this 2 to the other side, it will go and divide, so it will be 3 divided by 25 times 2, which is 3 by 50. So now we have an equation where B is the only variable I can find. So to find this, I'll subtract the two fractions, 3 minus 1, because their denominators are same. 3 minus 1 is 2 upon 50, giving me 1 upon 25. That means Bipasha alone will take 25 days, because 1/25 is the 1 day work of Bipasha. So this is how I have approached this question. If you want, you can go ahead and try multiple ways of doing it. It's not going to go that long, but the concept is similar. You will also use the similar concept. Now this next question is from fractions, and it is from percentage. There is percentage, there is ratio, and there are some numerical values. So how exactly can we approach a question like this? Let's have a look. 20% of the monthly income is spent on house rent. Remaining, he spends R on traveling. So this R is what we are finding, okay? The traveling fare, or whatever that amount is, we have to find out that value. The amount he saves has been compared to the amount he spends on food, and those two are in the ratio 3:2. We have been given that the house rent is 4,000 less than the amount he saves. That means the house rent has been compared to the amount he is saving. And finally, what we have been given is the monthly income, 25,000. So 25,000 is the 100% money he has. So I'll begin with that. When I have the 100% value, obviously that happens to be the primary information that we have. So I know the 100% money he'll have is 25,000 rupees. First of all, because I know that 20% has been spent on house rent, I can find 20% of this, because 20% was the house rent is the first value given to you, so 20% of the total. How can I find 20%? 20 is just obtained from 100 by dividing by 5, right? 100 divided by 5 is 20, so I'll divide by 5 this side again. What does it give me? 5,000. So this 5,000 is the house rent. Okay, I got the house rent as 5,000. Now, you see, if you look at the question backwards, the house rent has been compared to the amount he saves. This is the information given to you. And clearly they have told you the house rent is 4,000 less than the amount he saves. So if you have to read the statement otherwise, then the amount he saves will be 4,000 more than the house rent. So if the amount he saves is 4,000 more than the house rent, clearly by adding 4,000, what I'll get by adding 4,000, 4,000 plus 5,000 is 9,000. So I can clearly say that 9,000 is the amount he saves. Okay, I got the amount he saves as 9,000. Now the amount he's saving has been compared to the amount he spends on food. So, well, that's now in the ratio 3:2. So clearly the amount he saves is 3 units, while the amount he spends on food is 2 units. And I know that the amount he's saving is exactly 9,000. So this 3 units here represent 9,000. I'm going to figure out 3 times how much is 9,000. Because I know the ratio, I know the value. So when you have the ratio and the value, you just compare them to find the value of 1 unit. So if 3 units is 9,000, then 1 unit has to be simply, I'll think about dividing 9,000 by 3 gives me 3,000. Well, if I'll divide 9,000 into 3 parts, each part is 3,000, and I know that whatever amount he is spending on food is now 2 units, or 2 units as compared to 2 units of what he is spending, or what value you got as 1 unit here. I hope this is making sense. 9,000 was the amount he is saving, and because the amount he's saving is in the ratio of 3:2 with the amount he's spending on food, so whatever value I got as 1 unit, upon multiplying by 2, I will be able to get the amount he is spending on food. So clearly the amount he's spending on food is 3,000 times 2, which is 6,000. So now you know the total was 25,000. From 25,000, whatever amounts we got, we have to get rid of it. 9,000, 6,000, 15,000, that's the sum, and another 5,000 on rent. So the total is 20,000, right? Upon adding all this, I got 20,000. So the only amount remaining that he has is the difference, which is just 5,000. So 5,000 has to be the amount he is spending on traveling. Thereby, the answer has to be 5,000. Because the question had both percentage, ratio, and all sort of numerical values, this is the best way I could approach in the shortest way. Let me know if you have other ways of doing it. Okay, the next question is based on mixtures, ratio and mixtures, right? So not only things are in ratio here, it's all in percentage. So let's do this quickly. A mixture contains 60 liters of pure milk. So that's the amount of milk you have initially, 60 liters. 10 liters of milk is taken out. Clearly, you have to remove 10 liters. Giving me the amount of milk now I have is just 50 liters. 25 liters of water is added. So the amount of water you have added now is 25 liters. So that is the amount of water. And now the next part is after 60% of the mixture is taken out. So clearly, if you are removing 60% of the mixture, you are assuming the mixture is thoroughly mixed. So you are removing 60% of milk and 60% of water, right? So you can find out. The reason I'm doing them separately is because the question wants me to find the ratio of milk, water and juice, because they are bringing juice again, okay? So You want to find them separately so that you have the values very clear to you. So if I'll remove 60% of this, then I have to consider only 40% because that's the remaining amount of milk in the mixture. So 40% of what you have is the amount of milk that you have now. Okay, so clearly you can get rid of all the zeros and you just get the answer 20 liters. The amount of milk you have is 20 liters, while the amount of water you have is just 40% of what you had initially. So 40% of 25, it has to be 10. Yeah, you can get rid of 25 and 100. 4 quarters is 100. So 4 times 10. So 10 liters of water is what you have and 20 liters of milk. But after removing the 60% of the mixture, 40 liters of the mixture of milk and juice is added. Now 40 liters of the mixture of milk and juice. Now understand that out of this 40 liters, again the mixture contains 60% milk. So this 40% now contains 60% milk and the remaining 40% will be juice now. Okay. So 60% of 40 liters, let's find that out quickly. 60% of 40. Again, if you cancel out zeros from both numerator and denominator, gives you 24 liters of milk. So don't forget, we already had 20 liters of milk in the mixture. So upon adding this side, it gives me the total here, the total amount of milk I have now is 44 liters. Now water is unaffected, this is the only amount of water I have, while juice is 40% of 40 liters. Clearly 40% of 40 has to be 4 times 4. Yeah, get it out, get all the zeros out, you get 16 liters. So 16 liters of juice you have, this is the amount of juice you have. Question wants you to find the ratio of milk to water to juice. So you got all the values. Find their ratio. 44 is to 10 is to 16 and you can divide all of them by 2, giving you 22 is to 5 is to 8. Well, the answer has to be 22 is to 5 is to 8. I'm sorry, this is hidden. So it is just, if you reduce all the numbers 44, 10 and 16, they are all reducible. So I got 22 is to 5 is to 8. This is the final answer and this is how I got the answer for this question. Please let me know if you have approached in a shorter way and if you think this can be done other ways too. Now, I have considered few questions from quadratic. Now, quadratic equations is one such topic that is tested in all competitive exams and it's one of the most important topic we have in algebra. So, you want to be quick, yeah, and you want to make sure that whatever you're getting is the right answer. You want to be confident with that as well. This is the common pattern of all questions from quadratic, okay. They'll ask you 2 equations or they'll give you 2 equations and you have to compare their answers and see if there is any relation with the solutions you get for the 2 equations. So how do you begin? You look at the first equation and there are all sort of numbers 3, 18 and 15. Before you begin, you want to get rid of the common variables, not common variables, sorry. You want to get rid of the common number that has divided that can divide every other number here. So clearly 3, 18 and 15, they are all divisible by 3. Yeah. So if I divide the entire equation by 3, then it just becomes 3 divided by 3 is x, so x squared. 3 divided by 3 is 1, so just x squared. 3 divides 18 here gives you 6 and 3 divides 15 to give me 5. So this is the first quadratic. If you look at the second quadratic, again everything is divisible by 4. So upon dividing by 4, my equation becomes much reduced or much easy to solve. It becomes x it's in terms of y, so it's y squared minus 4 times 2 is 8 and 4 times 1 is 4, so 21y, and 4 times 8 is 32, so 80. Now, I think you know how to approach questions like this. When the quadratic is very simple, when the leading coefficient is 1, then there is so less work to do. What you do is you look at the last term, the constant term. You want to split the constant term into 2 factors such that they multiply to give you that number 5. Now note that the product here is positive. The product of 2 numbers is positive only when the 2 numbers have the same sign. So you want the factors to have the same sign, and now you want the factors to also add up to minus 6. Clearly you want the sum to be negative and the product to be positive. So the 2 numbers you are choosing must be both negative, because multiplying 2 negative numbers give you a positive product and adding them up still gives you a negative answer. So clearly 5 is a prime number and there is only one pair that can give me 5, which is 5 and 1. And because of this negative 6 as the sum, I have to be confident that these 2 numbers have to be minus 5 and minus 1. So the final value of x, which makes this whole equation 0, is not the exact factors we got, but the opposite of what values you have. Why opposite? Because upon factorizing this, because I got the factors as minus 5 and minus 1, I can rewrite the same equation as x minus 5 and x minus 1. So we are trying to make each bracket 0. So to make each bracket 0, I have to put the value opposite to what I have. So what minus 5 is 0? Definitely the same number but with the opposite sign. So 5 minus 5 is 0, 1 minus 1 is 0. So those values which makes the solution, or those values which makes the whole equation 0, those are the solutions of a quadratic. Okay, so clearly whatever factors you get, you just have to go ahead and consider their opposite values. Be confident with that. So you got the 2 zeros of the first equation, so x here clearly has to be either 5 or 1. Now let's have a look at the second quadratic. If you look at this quadratic, they have given to you AT as the product, which is a positive product. So clearly again the 2 numbers must have the same sign, and the sum here is negative. So I'm pretty confident that I have to consider the numbers of the same sign. Not only same sign, it has to be negative. Now 21, think about 80. You know that 80 comes in the table of 8 and 10. So you will go ahead and write down 8 and 10, but no, it is not going to give you 21. Right? So if you split that 10 into 2 times 5 now, and you try with this pair, 8 times 2 is 16, so 16 times 5 should also be 80. A lot of you may know that already. So I clearly see 16 and 5 will add up to give me that 21. So because the sum here is negative, I am very clear that it has to be minus 16 and minus 5. Minus 16 minus 5 is minus 21, and upon multiplying them I get positive 80. So because my answers are minus and minus both, my final answer for y is just the opposite of what factors I got, giving me 5 and 16. We got both the solutions for both quadratics. Now how to compare? You clearly see one of the solution is equal. Yeah? So x can be equal to y in this case, or else y has to be greater. Yeah, because the other value of y we have here is greater. So the answer to this quadratic, or the options from the given options, what we can write is y is either greater than or equal to x. Because one of the value is equal, 5 will be equal, or else 16 is greater than 1. So therefore y is greater than equal to x. We have this option, y is greater than equal to x, go for it, and that's it. You're done with this question. This is how you approach quadratic based question. You really don't have to remember the quadratic formula, especially if you're doing, or you're studying for a competitive exams, okay? The fact is, they will always test you with the basic knowledge. So these are the things that you have studied in your main grades like 8, 9 and 10. Okay, in class 8 you study factorization, factorizing into groups like this. Yeah, in class 9 and 10 in some schools or in ICSE especially, it is taught in class 9, while in CBSE you learn in class 10. So maybe in your local boards or your regional boards, you must be doing in either of these grades. So this is the basic way you solve a quadratic, just by factorizing, or we also call it that, the method is also called as splitting the middle term. So, yes, hi, good morning. No one is watching. It is sad. No one is watching, but I'm sure any one of you who will be watching this might be able to do the topics that I'm doing with more confidence. Okay, that is what I'm hoping for, and I'm sure people will join. I'm very hopeful people will join, and they will come to this. Moving on, there is one more question from quadratic I would like to do, because the questions might not be so easy every time where things are all reducible, right? The numbers given to you might not be something that I can reduce. If you look at this question, this is a question where numbers are all different and there is no common factor here clearly. So how exactly do we do a question like this? You have two quadratics given to you. Again, the procedure is same. You want to deal with one at a time and find their solution and their relation ultimately. Now, one thing, you cannot reduce it, you cannot divide the whole equation. So we look at, in such cases, when there is no common factor and your first term is multiplied to a number other than 1, then we want to make sure that there is a pair of number that multiplies to give me the product of the first and the last term. So 50 and 9 are my numbers here, so I have to times them first. I want to see their product. Okay, so 50 times 9 is definitely how much? 450, right? Now you want to find two pairs that adds up to 45 and gives me 450. Okay, now clearly I know that there are many pairs which will give me 450. So I want to try with different things. First of all, clearly 50 and 9, the two numbers that we already multiplied, do not have a difference of 45, right? So I want to find out another pair that can help me get 450. So instead of now, what we can do is we can be a little clever. Okay, we have the same numbers 50 and 9. So I want to go ahead and split the numbers. So what I can do is, maybe instead of not taking 50, if I'll divide 50 by 2, then I can times it by 2 this side, and upon doing that, the overall product is unaffected, meaning you have balanced it, right? Dividing one number by 2 and multiplying the other by 2 gives me how much? 25 and 18. Clearly, that is again not a pair of factor that can make that 45. So what will you do is, you can think about splitting this 18 further, or maybe you can think about splitting this 18 into 3 times 6, because I am hoping that one of the numbers will help me get something. So 3 times 6, right? So this is the way I can actually do multiple trial and error to find out what pair of numbers could make 450. Okay, now similarly 25 can be written as 5 times 5. So check it out. 5 times 6 is 30 now, and 5 times 3 is 15. We are very lucky here because we just got the pair. 5 times 6 is 30 and 5 times 3 is 15. So 30 into 15 will also be equal to 450, and clearly their sum is 45, right? I figured out that my pairs here have to be 30 and 45. Again, because of the negative sign and a positive product means same sign the number should have, and because it's minus 45, I have to make sure I consider minus 30 and minus 15. So these are my factors. But because my first leading coefficient was something else, I am not done yet. What do? There is one final step you do with the factors you get. As I did in the last question, the factors will be taken in the opposite sign. So I have to take 30 and 15. They are the sign, they will be the new sign of the numbers. One additional step I'm going to do is I'll divide by 50 this leading coefficient. Anything that you have as a leading coefficient will now go ahead and divide the two factors you got, giving you 30 by 50 as one factor and 15 by 50 as the other. So remember, this works when your leading coefficient or the coefficient of x squared is something else. Okay? So finding the factor is the main thing, right? Finding the pair of factors is the main thing. And I showed you how exactly can you do in multiple steps. Or if you can think about the number that 45 comes in the table of 15. If you know that, then you could have written it as 15 times 30. Yeah? So sometimes it is possible that you get that pair of factor in one step. If not, then as I showed you, you can split the numbers and try with different pairs. So I got the answer 30 and 50, so that can be reduced to 3 and 5. So clearly one value of x is 3 by 5, while the other value here, they are both reducible by 5. So 5 times 3 is 15, 5 times 10 is 50, 3 upon 10. Yeah, I got the two values for x. Similarly, now let me go ahead and solve for part 2. Okay, or the second equation. To do the second equation, the procedure is same. I multiply 25 times 12. What's their product? 25 times, now to be very quick with this, I know 12 can be written as 4 times 3. So 25 times 4 is 100. So 100 into 3, 300. Okay, so the product here is 300. So what do you want to do now? You want to find a pair of factors that multiplies to give you 300 such that their sum is 35. Again, because the product is positive, I want the numbers to be of the same sign. So if the numbers are of the same sign, you want to add them, right? The numbers of the same sign always adds up to make that number 35. Okay, so think about it again. So 300, it comes in the table of multiple numbers, which is one of the number I can think is again 15, right? 15 times 2 is 30 and 15 times 0 is 0. Congratulations, I just got it in one step here. I just tried with one of the numbers that appeared before. It's just a hit or trial, yeah? So because I got one of the pair before as 15, so I'm trying with the same value. I got 15 again. So 15 times 20, I tried and it worked. So if I got the pair of factors, 15 times 20 has to be 300, and because the sum here is minus 35, again the values here will be negative. So the final answer is just the opposite of what you got, 15 and 20, but because the leading coefficient is 25, you want to go ahead and divide by 25. So the answers here now will be different. 15 and 25, they are both reducible by 5 again. 5 times 3 is 15, 5 times 5 is 25. 5 times 4 is 20, 5 times 5 is 25. Now, interestingly, we got the same. Okay, previously the two answers were 3 and 5 and 3 and 10. Now again I got one of the values for, this is the value of y, and I got the value same. One of the value for y is same. Now compare the other two values of x. This was 310. Now this is how much? If I have to write in terms of 10, then I will write this as 8 upon 10. So clearly y here is either equal to x or it has to be greater than x, because upon simplifying and comparing the two fractional answers, I got that y is greater than x. So the option we have here is again y is greater than or equal to x. Equal to in case when the value of the solution is 3 by 5, and greater when if I consider the other pair. So this is how I approached questions based on quadratic. I showed you 2 examples. Remember, this is a shortcut, this method of working out with the number at the front and dividing the final answer. I never learned this in school. It was never taught in school like this. But this is the common method which is approached for competitive exams. In your school days, you have to show your steps and you are really not encouraged to use shortcuts, yeah? But for competitive exams, it's up to you. You want to save your time. You want to be highly efficient and get the answers right in a short amount of time. So just finding the factor is the main part and then dividing by that leading coefficient when it is something else than 1. That is one additional step we did and you are done. You got the answers, you compare the answers and see which one is bigger or if they are even equal. So this is the kind of questions they ask you, and yes, only meme has answered this and y is greater, but well, y is greater will be a wrong answer. You have to say y is greater than or equal to, okay, because it makes sense. One of the values are, yes, because we got one value, one solution is equal, so we cannot miss that. How many questions are we going to do next? Well, is there anything you want me to go through? I think I have a question from vote and stream. I have a question from probability. I'm actually trying to go through multiple topics so that it does not become monotonous and you study every concept in a different way, or I just wanted to help you like that. If there is any topic you want me to go through and discuss something importantly, I will do that for you. Moving on, vote and stream. Let me tell you, again in school days, we used to have this old school method, okay? We used to approach questions in a very different way. We used to do especially with 2 variables, x and y. But now, no, I don't think you should approach it likewise because it's more important that we save time, especially in exams. And obviously, when you are on the verge of saving time, you do not want to make any sort of silly mistakes, or you do not want to spend minutes doing a single question. So a question like this can be done with a very minimal, with less steps you can do it definitely. So let's have a look how exactly can you do it without having to do multiple steps, and let's go through it. A boat running downstream covers a distance of 40 kilometers in 5 hours. So whenever you have distance and time, what you figure out is the speed. So now I'm not figuring out the 2 speeds in 2 variables. I'm doing in 1 variable. I'm just saying speed downstream, okay? So downstream speed, ds, downstream speed, I can find it by simply taking the ratio of the distance covered to the total time taken. So downstream speed is 40 divided by 5, which has to be 8 kilometers per hour. Now covering the same distance, it takes 10 hours. So upstream speed, obviously it is logical that when you're going against the current, your speed has to decrease, right? So it takes 10 hours to cover the same distance. 40 divided by 10, the answer is 4 kilometers per hour. Now you want to find the speed of the stream. So here is the shortcut we want to apply. Remember, when they ask you to find the speed of the stream has its direction. Upstream, it's opposite, and downstream, it is like, it's this, downstream is the speed of the stream, or downstream is when you have the speed of the stream along with the speed of the boat. So here is the shortcut you want to remember. If the question ever wants you to find the speed of the stream, then what you really want to do is take the downstream and the upstream, find their difference and the average, or basically you want to half it, okay? So what I'm doing, downstream minus upstream speed divided by 2. Had the question been asking you about the speed of the boat, we would do otherwise. We would add them up and divide by 2. Now why does this shortcut work? Are you interested in knowing that? I don't know, because sometimes, my students are just interested in shortcuts. They really don't care how did it come from, where did it come from. But if you're someone who wants to know why this works, I would want to go ahead and tell you. Okay, there is a very basic concept actually. As I said, what happens is downstream you have two speeds, the speed of the boat and the speed of the stream added up. So when you know the downstream speed, you actually have the speed of the boat added to the speed of the stream. Whereas when you are coming upstream, then the speed of the boat, from that you want to subtract the speed of the stream. Yeah, that is the concept of upstream and downstream speeds. That is the difference. So I'm saying that this downstream speed is A and upstream speed is B. If I have to go ahead and find the equations, or if I want to go ahead and add the two equations, you clearly see that this 2 will cancel out, giving me 2x, because upon adding, the equal and opposite terms will simply cancel out, gives me 2x equals to a plus b, and x equals to a plus b upon 2. Remember what was a and b? A is the downstream speed and b is the upstream speed, and x here is the speed of the boat, y here is the speed of the stream. So by adding the two equations, I'm just telling you why this works. So I got that the speed of the boat is always the average of the two speeds, a plus b upon 2. But now instead of addition, if I was to subtract the two equations, then my x's would cancel out, right? X minus x is 0, but now we are doing y minus of minus y, thereby giving me 2y should be equal to a minus b, y equals to a minus b upon 2, which means to find the speed of the stream, take the downstream speed, subtract the upstream speed and divide by 2. That is exactly what I did here. 8 minus 4 is 4, divided by 2 is 2. So answer has to be 2 kilometers per hour. Isn't that simple? Honestly, I never knew this when I was in school. I mean, we were never taught it likewise, okay? But I think this is exactly the method you can approach, because it takes you minimal steps, okay? And this is how exactly you got the answers without having to do much. In your exam, you would just find the downstream speed, or just find the speed in one direction, find the speed in the opposite direction. And because the question told you to find the speed of the stream, the reason why we subtract is because it's like following the direction. Speed one side is positive, then the other side is opposite. That is the reason why we subtracted and we found the answer. Very simple, yeah? All right. Now, the next question I have is from probability, and this is also one of the topic. Now let me tell you, okay, probability is quite easy till class 10. After that, what happens is when we study maths further for class 11 and 12, things become a little complex. Like you will see a lot of students struggling in 11, 12, though their class 10 marks are very decent. Okay, it's quite normal because things become, more advanced. And for a question like this, they really have this combination formula coming up, and they ask you to, or we used to do it using the concept of combinations, and then we used to do it. But I am also assuming that a lot of students giving their competitive exams, they might not have done those topics, like Chinese remainder theorem. That is one topic I did in my BSc. I see your questions applicable to that theorem, but you really cannot use that theorem because you have not learned it, yeah? Or similar to that, I'm assuming that a lot of students who will be giving their competitive exams will not have clear idea about the concept of permutation and combination. So for a question like this, there is a way you can approach it without having to do the formula part, or without having to bring in your combination concept. So but you have to be a little imaginative, a little more creative, and open up your mind to understanding the questions and thinking about scenarios. That is my suggestion. Question tells you that there is a bag and it contains 6 white balloons and 4 black balloons, so a total of 10 balloons. Yeah? You are finding the probability of drawing a white balloon and a black balloon. Now the thing is, when they say draw a white balloon and a black balloon, they have not told you to get in specific order. It's like you can get white first and then black next, or black first and white next. Now, in case of understanding the concept of sets or even probability, the word and or has a meaning, or we interpret them mathematically. How? When I say this and that, it means it's like conditional, this as well as that. So when it is conditional, we multiply, okay? It's like the and rule and the or rule, we call it. But in general, you need to understand. When I say or, it's an option. It's like this or that. Yeah, if I'll say, what is the probability of getting heads or tails? Then the answer is 100%, because either way you will get heads or tails only. So one of the option, or as in you have the option of getting heads as well as you have the option of getting tails. But when I say probability of getting head and tail, it means you are getting head first, tail next, or you could be getting tail first and head next. That is the probability of getting head and a tail. So the same concept here, the probability of getting a white balloon is how much? 6 out of 10. The word suggest and means, as I said, it's conditional, so we times it. Okay? And as the word suggests, I have to times it with the probability of drawing a black balloon. Now think about drawing a ball. You have already drawn, not ball, it's a balloon. So you have drawn a white balloon. Now for the second draw, the number of balloons you have is one less because you have drawn already. One of them is already drawn. So you want to think about the remaining number of balloons now, which is just one less than the previous. So the number of balloons, total number of balloons I'll have is 9 in the second draw. Well, I want to draw a black balloon now. So the number of black balloons is not affected because I'm assuming that I've picked a white one first. Yeah? So the number of black balloons is still 4. So the probability of drawing a white balloon, this is the probability of drawing a white balloon followed by a black balloon. But the question does not tell you to follow the order. The question tells you draw a white balloon and a black balloon. So it can be otherwise. Now otherwise means you could draw 4 black balloon in the first case and you could draw 6 out of 9 balloons for white. Yeah, because you want to draw, you have 6 options to pick from. So thereby, as I said, this or this. Now the thing is, when I say or, it means optional. Now look at the two fractions. Upon solving the two fractions, because the numbers are same, numerators are 6 and 4, here also it's 6 and 4. The denominators are 10 and 9, here also you have 10 and 9. So the logic is, instead of not writing them and adding them, you can simply say it's the double of what the probability is. The reason why I'm doubling it is because I have 2 scenarios possible. It could be in one order, white followed by black, or black followed by white. So it makes sense why I have to multiply that 2 at the front. Okay? Because, as I said, because I have 2 options to pick in 2 different orders. So thereby, I will reduce the fraction now, 6 and 3. 3 divides both 6 and 9. 3 times 2 is 6. 3 times 3 is 9. And now 2 times 5 is 10. Alright. So I'm doing this 2 here, will multiply the numerator, gives me 2 times 4, 8. And 5 times 3, the answer is 15. So 8 upon 15, that is the answer, or that is how I approach this question. Or else they will end up giving you the concept of combination for a question like this. I don't think it is much needed. I think it's more of being imaginative, or just visualizing the scenario. Okay, this is how I figured out this question, and I would teach, because I remember doing a question like this with even your 10 students, class 10 students, from different curriculum. And this is the technique. You have to think about the order, and because had the question said, find the probability of drawing a white balloon followed by a black balloon, then we would not have times that 2, because they want to go in a specific order. Okay? There is only one chance for that, not two. But because it was optional, I could go in any order. That is the reason why I went ahead and multiplied with that 2 outside, giving me 8 upon 15. So this is how I solved a question from probability. Okay? Well, Rishabh, welcome back. Class 10 questions you want me to do. This is all about understanding the competitive level exams. I will be delighted to start with class 10 very soon. But for now, because I had considered someone's request based on doing the questions from competitive exams, these are the first set of questions I could get from all sort of competitive exams. Okay, if there is any book you want me to solve for you, please let me know, and I will definitely help you getting to each of the topics, and I will help you with any topic that you find doubtful. All right. So these are the first set of questions I wanted to do. That's it for now. The remaining, I have more questions. Obviously, it does not end here, right? We have so many other topics to consider: simple interest, compound interest, even in percentages, there are other kind of questions: discount, profit and loss. So these are your common core topics that will be mainly tested in all sort of competitive exams. So I'm trying my best to cover as many things as possible. But for now, for today, this is it. This is the starting, paper I did, or this question. My bad. I think this question just got hidden a little. You see, this is the exact kind of questions you will be tested on, and I hope I was able to help you. Only Meme is asking me to do physics questions. Well, honestly, physics questions, I'm out of touch with physics from a long time. I used to teach physics, I used to teach science before, but I've been out of touch. I just like the numerical parts, like numericals based on electricity or maybe light. I used to find that part more fun, but currently I am more into maths, or I want to focus on doing maths more, because I think if I have little expertise in any subject, I would say it is in maths. Moreover, in science, I am more of a chemistry person. I do teach chemistry as well, but maths is more fun for me. I tell my students all the time that it's more fun to do math class for me rather than doing science. In science, I feel like there is too much of talking, while there is too much of explaining. But in maths, it's like if I'll do one thing, I know my students will understand the other thing, like basic things, they're always in touch. So I don't know, I feel very much confident and very happy to solve mathematical problems rather than getting into science. So honestly, I have no plans of getting into science for now, but I don't know, in the coming future, who knows? I really cannot say anything. Well, you can just let me know through your comments and through any post and wherever you can. Just let me know if there is any topic or anything that you'll need my help in, and I'll be happy to help. So you can call me. My name is Sujata, so yes, you can call me. Of course, you can call me. Yes, that is my name, Sujata, Sujata ma'am, Sujata, whatever you're going to call me, just go ahead and call me that, okay? or just call me by my name, doesn't matter. So only meme, are you on your doing your school level right now, or are you doing or preparing for competitive exams? So if you are someone who is preparing for competitive exams, then I'm sure this particular session has been very helpful to you. And you can also update us about when your the next exam is. You can always do that. And I guess that is it for now. I would want to continue with a lot of things in the coming session. So maybe I'm planning that for, okay, that's very interesting. You're doing your class 12 boards, which is really interesting. Class 12 has a lot of topics that I like. So not everything, but still I do like a lot of topics out there. I do teach all the school level students. Mainly I teach from 8 to 12. So even in class 12, if there is any particular topic that I should go through, then please let me know. If you have your physics exam on 2nd December, sit back, prepare for your physics exam, and I'm sure you will do nice. I'm sure it will go well. And well, that is it for today, I guess. I will come with more questions next time, and it might be like more of different questions. So I will end this session here today. I hope to see you again. That is it.